Spring Boot a little bit. Then we're going to talk about some design patterns. We're going to have a breakout session for 1A. I'm going to break you guys out into teams of 3 or 4, and you can discuss what you've already done and where you might need help. So if some of you are lagging a little behind, this will give you an opportunity to ask other people questions on your little breakout teams to help each other along. Remember, it's due tomorrow night at midnight or 11:59, it says on there. And so I'll be able to work on that on Saturday morning and Sunday morning to get you guys feedback. So you can hand in the final the following week on that one. Okay. And we're also going to go over more of the Spring Boot operating model, how that all works, and then any questions that you guys have, you guys can interrupt me while we're going through it. But before we get things kicked off, are there any questions on the lectures that you guys have listened to? Are you listening to those videos? They are done extremely well by one of the guys that actually helped to write all the Spring Boot and architect it. So Dr. Winters. So any questions on that stuff? Anything that needs clarification?
Well, I really liked the way that they do the whiteboarding, where, like he's standing in front of glass or something and writing, and I thought it was great.
It's pretty cool. And I found out he's actually doing that with a mirror. And I don't know exactly how he did it. I've got to talk to him and say, how in the world did you do that? Because that's super cool, right?
I want to shamelessly copy that and make myself look smart at my job.
Yeah, no doubt, no doubt. All right, anything else, guys? Any other comments? Or if you have not been listening to us, please go and listen to them and watch them. I've been going through all these lectures as well, listening to them as well. I take a nice walk and I listen to the lectures. Sometimes if I'm like, wow, I pull out my phone and look at and see what they've drawn on the board. So very interesting stuff. Okay. All right. Let's talk real quick about microservices. Unless anyone has any other comments or questions.
Actually, I had a question, Professor. I put it in the discussion too, so I can document the answer there. But you mentioned an auto grader, and I think it was like in one of the documents about like the assignments on that assignments tab. Is that just the unit tests, or is that like an old thing from like another class?
No, the auto grader, I actually am going to use ChatGPT to help auto grade your assignments. I've got some best practices from Dr. Schmidt that he gave me for prompts, and then I'm going to suck your code into ChatGPT and grade it against a rubric that I have. So
Okay.
that's the auto grader.
So yeah, just commit the code. Don't need to submit any tests or any evidence other than that.
Nope, just a little README. There should be like a README file that you put in there telling me what you did. If your test passed, or if a test is failing, that's okay. Tell me that a test is failing. But I'm going to suck your code in. I'm going to run those tests that are already there in IntelliJ. And I know Reed knows all about those because Reed found out that they do work. If you let them work. If you try and write your own, then it's a little more problematic. Did I sum that up right, Reed?
Well, no, I think the mistake I was making is I had run the application so that I could test the endpoints on my own, just one by one, as I was sort of piecing it all together. And I left the application running and tried to run the tests. And it seems that the test application wants to start its own application. And so they don't.
Oh, so you were.
Yeah, you can't do them both at the same time. They definitely, I've seen it fail in person.
That file path that I mentioned when I answered your post about on Piazza, that report section, you can get a log. Like if you log, like try and catches and errors and stuff like that, or maybe just print statements, like the high IQ move is to have the print statements that that HTML will actually show that output from the program. And that's a good way to debug if that's what you're trying to do.
Yeah, there's actually, it'll give you that HTML in the log once the test is working. But what I was having, like, it was catastrophically failing before I realized I needed to shut the main application off.
Yeah, I imagine you had some port conflicts. I bet that was the problem.
Yeah, that's what I expected as well. It says that it's on port 9092. So if you're running it on port 092, if you're running the actual application on your local through that, it'll be on port 9092. And then once you run the tests, it's also going to try to use 9092.
On the same port. Yeah.
Which that would cause a port conflict.
Yep.
I also did have a question about the README. I already submitted the assignment, but I didn't submit it with a README. So
That's fine. Just you have until midnight tomorrow. Just a
all
little
right.
README. Tell me if there were any issues. That's all.
All right. Any specific naming convention for the README?
README.md is great for me.
Okay.
I like Markdown better than TXT. And then don't forget, many of you have already invited me or to your GitHub or your GitLab accounts. So, do that. And don't forget to add in that text where the link is so I can go grab your code. Okay. So if you need to resubmit, if you didn't put the link in the text, please make sure you put the link in the text to your GitHub repository.
Yeah,
or GitLab repository.
because you said GitLab was something you can add on GitHub. It says like add as collaborator. Like that's what I did. That's
Yep.
right.
I saw that, LaShawn.
Okay.
Yep. And in GitLab, I said maintainer. And the directions from last week had that. So either one works. Okay. All right. Any other questions till we dive into the content for today? All right, let's dive in. First off, microservice architectures. When you guys hear the term microservice, what do you first think of as far as software engineering techniques go?
Single responsibility.
Let's say that again, Hamza.
Single responsibility. Like it's
Single responsibility. I like that. I like that. Anyone else?
I think of machines running like single tasks, if that makes any sense.
Yep, machines running single tasks. Very good. Anyone else?
Yeah, I mean, when I think of a microservice, I think of something that is tightly cohesive, loosely coupled, and usually built around a single specific entity. And then I typically think of like the generic get, put, post, delete, patch, built generically so it's easy for anyone to integrate, not for just like some specific use case.
Perfect. I love it. These are all great answers. Anyone else?
Yeah, basically the same thing, like smaller tasks running to be able to provide like a quicker output.
Sometimes quicker, sometimes slower, believe it or not. One thing I think of when I think of microservices, first thing pops in my head is containerization. I think of a whole bunch of containers floating around. That's an implementation side. Anyone else? You guys could teach the lecture today because you already covered a lot of the main key topics, which is loosely coupled, highly cohesive, fine-grained services, single task, and the other key aspect here is they communicate via lightweight protocols. Right? back in the 1990s, there was this concept called Corba. I don't know if any of you recognize, maybe some of you old timers like me remember Corba. Common Object Request Broker Agents. Corba. It was not lightweight. It was supposed to be lightweight, but it was kind of the foundation for having distributed microservices that were running in lots of different places. But the lightweight protocol was not there. It was very heavy. It required a recompilation of code. It was very difficult to work with. With the birth of some of these more lighter weight protocols, HTTP actually is one of them, but others like WebSockets and even some others that have higher abstraction layers like gRPC, actually lower, make it easy for us to create these microservices that can share information between each other, right? And the idea is that we can take really large monolithic programs and decompose them into small independent services that can be developed and deployed independently and separately from each other. One of the, and these are some great resources that are on here that you guys will be able to get access to after you, if you look at the PDFs, you can download and read these articles. One of the things that we're seeing, especially in cloud service providers, is the plethora of microservices. People have gone hog wild crazy with them. And in some cases, it has caused some issues, which we're going to talk about some of those issues as well, right? One of the most important things that we need to realize with microservices is we still need to architect. We still need to architect the system. And sometimes we forget that and we only focus on the individual microservice. And you guys are going to learn through these applications that we're writing in the assignments that we have to look at the whole picture as well. We can't just focus just on one microservice by itself. We have to look at how it interacts with other microservices and or resources that are out there when we're looking at systemic views of things. So keep that in mind as we go through things. You've got to understand high-level picture as well as the microservices. There tends to be a problem with microservices. One being is that they're loosely coupled. So your concern only focuses on the one microservice. And then you're saying, well, it's loosely coupled, so I can do whatever I want and connect it to whatever I want. Turns out when you think at the system level, there is still some coupling, even though it's looser coupled, that you have to pay attention to. So, and I'll show you an example of that with a case study that I did on AWS, which was very fascinating. If you guys have any questions, I will bring the chat up here, but I'm not going to be looking at the chat as much. So please bring it, please, interrupt me if you want to make a comment as well. Okay. All right. So am I already on the gotchas or did I go too fast? Oh, I'm already on the gotchas. All right. Let's talk about one of the biggest gotchas. The AWS Thanksgiving week East Coast outage of 2022. Anyone remember this? No one remembers this. It was brutal. AWS was down for almost 12 hours on Black Friday on the East Coast. Now, for organizations that only had their applications running in one region, this was devastating to them because Black Friday is the largest retail day in the United States. And it used to be Monday after Black Friday was the online, but online biggest day is that day as well. It literally costs billions of dollars of online retailers of missed revenue. And it is a prime example of microservice architectures gone crazy. I did a full analysis of the outage that I guess it was November 2020, not 2022. on my podcast that you guys can listen to. It's fascinating. One thing that I love about AWS is they're very transparent on their logs and on what happened. So I went scouring through their logs to find out what causes catastrophic failure. And it was really fascinating because AWS, if you look at their services and how they're organized, they're all microservices. They did a great job at defining the individual work that each service did. What they forgot about was the systemic approach. And that outage was a cascading failure due to an update to one service. It happened to be the service that CloudWatch uses to monitor the services that supply all of the different capabilities needed to run microservices. So if you were to go on, and this happened quite a bit, retailers saw that their websites were down. So the very first thing you do is you go where? If you're on AWS, the first thing you do if your site goes down is you check for the services. Are the AWS services up and running, the ones that I use? And guess what? They were. At least that's what they were showing. So when you went to the website to look at all the services, they were all showing green. So as an IT professional, what's your next thing that you do? Anyone? What would you do? AWS is up and running green. Everything's fine.
I would check my system logs, I suppose.
Yeah, you check your own logs. It must be my problem, right? Because AWS says everything's running. And that's what happened. And a lot of online realtors were checking and saying, look, AWS is fine. It must be my code. And they weren't communicating with each other because, hey, it's, online realtors, they don't do that, right? The thing that's supposed to check and set all those to yellow or green is a microservice. And this microservice actually pools all the other microservices and say, are you running? Are you running? And then it reports out, yes, I'm running. So it's kind of the heartbeat that they had. And they used pooling to do this instead of drop sockets or other techniques, event-driven techniques. But this microservice was down and was not coming back up. It was stuck. It was a bad code patch that someone pushed up, and it was stuck in this loop that it couldn't get out of. In fact, it even reported itself as running. So when you go and look, all of the other services were dependent on this service giving the status of the other services. So if I was a microservice and I required, and let's say that my microservice was named Darren and I had a dependency on Jonathan, that was I depended on some data coming out of Jonathan or some service that I would use from Jonathan. And I start up and I go, is Jonathan running? And he says, yes. And then all of a sudden I can't connect to him. Oh, it must be on my side. So I keep retrying. So they got stuck in these death loops. Why? Because what happened is no one looked at the dependencies, both explicit and implicit dependencies between the microservices. And until you started unraveling the dependencies, the runtime dependencies of these microservices, did you find circular dependencies, tight cohesion, tight coupling? And even though there was tight or strong cohesion in each microservice, there were all these runtime dependencies that caused these spiral loops that caused a deadlock.
So did they introduce like circuits in their service?
They've been going through and re-architecting many of these services to handle this. But if you're not paying attention systemically, or if you're not using some common, well-known practices like circuit breaker, right, for example, then you run into these issues, right? So it's very important when we're developing our microservices that we look at the design patterns for microservices, that we're developing them so that if we do have dependencies, that we know how to fail gracefully and notify others that we are down, instead of a central controller like they designed. Most of this happened because these microservices were being developed independent of each other, with no one looking over the whole architecture as a whole, right? So be mindful of these sorts of things with microservices. With monolithic programming, that rears its head much faster because it's all in one umbrella. I can see everything better, and I can manage it better. But there's a lot of downsides to monolithic programs as well, right? But there's trade-offs that we always have to deal with. Okay? Any questions? All right, let's keep going. All right, so it is extremely important. I'm going to emphasize this a lot throughout this course. Do not ignore these engineering principles of cohesion, coupling, abstraction, encapsulation, and separation of concerns when you're doing your development of microservices. Also take a systemic approach to make sure that you're not just moving bad programming techniques and scaling it into microservices that I can now run anywhere and everywhere, and now it's even harder to debug. In fact, there are some techniques out there that people actually write their code as one application, but have it divided out into microservices, but they run it in one application space, so it's easier to debug. Once I start moving into microservices that are distributed into separate processes, it becomes much more difficult to debug, right? So there's different techniques you can use, but these engineering principles are going to be critical for you guys moving forward. Okay. All right, let's keep plowing forward. All right, let's go over the Spring Boot overall model real quick, and we're going to go through how it all operates. If you look at Spring Boot overall, it's really using some design patterns in there that are pretty fundamental design patterns that have been around a long time and very useful, very tried out. And that's very similar to the model view controller concept. So if I look here on the left, a client, which could be a web interface, it could be an application, it could be another microservice, is going to communicate with the application or the microservice through a controller class. These are HTTP requests. Excuse me, right? Those requests are then sent down to the service class. That this is your business logic. This is where I'm actually going to do something with that request that comes in. So the controller class, the whole point of the controller class is to take that request and send that request to the appropriate service in the architecture. That's how the Spring Boot thing works. And then there's the model aspect or the model layer. That's where I'm going to handle storing and saving state, right? Whether it's a model attributes or relationships between different objects in the model, whatever it is. And that's where I'm handling all of that data storage and persistence, right? Then I've got a database where I'm storing persistently. And then on the top, I've got my repository interface. And this is where I can inject dependencies between classes into the architecture, right? And specifically between these service classes that I have. Okay. We're going to go in more depth on this, but this is kind of a high-level picture on how things work. Most of the work that you guys are going to be doing is in the service class, right? The model in these assignments is already going to be handled for us in most cases. The service class, that's where all the business logic is, and we'll have you write a little bit in the controller classes as well, so you can see how that all works. Okay. All right. Let's talk about some of the Spring Boot design patterns that are in there. The number one in here is convention over configuration. A lot of frameworks exist in modern languages today that use this same concept, convention over configuration. Can anyone describe this for us as a team? Because I need a little break from talking. Anyone want to dare? What does convention over configuration mean? Anyone? Simple example. I'll give a simple example. Okay. Convention over configuration means I'm going to put things in a certain location. For example, if I'm writing source code, I'm going to create an SRC directory, and all my source code is going to go in that directory. Now, does it mean it has to? Can I compile Java code without it being in a source directory? Absolutely, I can. Right? So convention means it's things I've decided I'm going to put certain rules around how I operate so that it's always used that way. So I don't have to think about where should I put my source code? Where should I put my documentation? Where should I put my tests? I'm using convention to do that. And we do the same thing in Spring Boot over configurability, meaning I want to be flexible and do whatever I want. Okay. One of the best examples of why this works is an example up on my wall up here. See these three things up here? These are books that I've written. Okay. The first one over here was a book that I self-published with a friend of mine. And this was a long time ago. And it took us forever to write that book, about 2 years to write that book. Why? There were no convention. We didn't know what we were doing. We didn't know what font to use. We didn't know where the picture should sit on the page. We made all that stuff up ourselves, right? The second book I wrote, which is this one up here, was with the publisher. And they said, here are the rules. And we were like, oh, this really stinks. We got to follow their rules. But that book only took us 6 months to write because we didn't worry about where the page number fit or on page. The third book right here, I already understood their rules. Same publisher. I already understood their rules and their templates that they were using. And I was able to write that book in 3 months. Right? Convention let me work faster. And that's the same concept with Spring Boot. Once you understand their conventions, then I can focus on what's important instead of all of the ancillary code around it. So that's one of the key patterns that's out there. The next one is dependency injection. And we're going to talk very specifically about this, but think of dependency injection as runtime injection of dependencies instead of build time. So it makes your code much easier to write and compile, but it can also mean that it might be more difficult to debug later on, possibly. But what it means is through the conventions that I have before, as a service needs another service, that service is brought in, and those dependencies are brought in at that time. Okay. Inversion of control, we'll go in more depth later, but basically, instead of application and library talking directly to each other or application talking to each other, I've got a framework that's handling the communication between things and the control on when a microservice starts up and spins down. Instead of it going peer-to-peer, it's more framework is controlling that. That's inversion of control. There's other design patterns that are used in Spring. You can read more about those in some of the design pattern books that I do believe are on the next slide. No, they're not. They're later. You'll see where the other design pattern books are. If you don't have a design pattern book in your catalog, either a PDF of them or a good website that you go to, you should start learning these design patterns. They will save you so much time. And you can even look them up on ChatGPT, but if you don't know what to ask ChatGPT, then you're not going to know what it's giving you back is valuable or not. So at least learn what these design patterns are best used for. This is good research that you guys should do on your own. Okay. All right. Let's go over convention over configuration a little bit more in depth. When I look at it, if I do it right in a framework, it means I have reasonable defaults in the framework itself. Meaning, where's my source code? Or if I don't pass in a parameter, do I have a reasonable default for that value that it gets assigned all the way down to that? That's a reasonable default type of situation. Okay. Also, only specify unconventional bits of data. If things are conventional, then that should be in the framework. That should be in the conventions. So I'm not rewriting the same things over and over again. The idea here is that the framework takes care of the redundancy so you can focus on the specialized or the unconventional bits of your application. Right? It also eliminates distractions. How many of us, like to watch cat YouTube videos or Instagram reels? Those are distractions, right? Same thing happens in our code. Sometimes we're like, wow, I want to do this mundane, brainless stuff over here that really the framework should handle on its own. And I should be focusing on more thought-provoking work and my business logic aspect. If I'm writing code that's marshaling data structures, that's probably the wrong thing that I should be working on. I should be working on business logic instead of marshaling and unmarshaling data structures. Okay, think of that. That's where these convention over configuration comes in. And then also it decreases the number of decisions that you need to make, which is important as well, right? Because I want to be able to focus on the important decisions and things that are repeatable and reusable, these design patterns, let those be. Let those work the way they are and give me the ability to focus on what's important. Okay, that's convention over configuration. The next one is dependency injection. So this is used heavily. It's one of the key tenets of Spring Boot. I've got, and you guys have already found this when you declare your services, and I declare those services, what happens is the injector will inject those services into the client and connect those at runtime. That's the idea. It allows for auto wiring and in a lot of cases, dynamic auto wiring, where maybe only in certain instances does this client need to communicate with this service. So I don't need that connection there if it's not used, right? Now, one of the downsides, as I've always mentioned before, is unless I have a robust set of test cases, it may be harder to debug these things if I'm not injecting that service ever, right? If it's only in rare cases and I've never done it before, then that could be an issue that you may run into. It also espouses loosely coupled programming. And as I already mentioned before, let me turn this off. It has separation of concerns in constructing and using these different services. Okay. Any question on dependency injection? We all understand it?
So like the Spring Boot, it like manages the life cycles. Is that essentially?
That's a great way to think about it. And that really fits into the next one, which is inversion control, right? Spring Boot is the framework here. So it's going to make sure that I have the right services running at the right time in the right threads when they're needed. So I don't have to worry about that stuff anymore. Where before, if I have application code, I'm going to call a library and I look for a return, I have to inject that library up front, right? I have to link to it or whatever with injection dependency or dependency injection. That happens as it's needed. And the framework is handling all that for me. Okay, does that make sense? You see how dependency injection and inversion of control work together? Okay. Silence means acceptance. Everyone got it?
Yeah, I feel like so it's basically like the container and it like auto configures to be able to allow the framework dependencies to run in the background. Is that essentially?
Yeah, you can think of it just like that. The main thread is the framework. So think of the framework as the main thread, and it's the one that's orchestrating when these microservices are being used and not.
Thank you.
Yep. Okay, great question. All right, here's the design pattern books. That's kind of fuzzy, but you can work it out. I know Dr. Schmidt was an author in some of these. So they're great books. I've got the design patterns book, the one up on the right. That's the one I use primarily.
I have that one too.
Yep. So learn these design patterns. You learn what they're used for. You don't necessarily need to understand how they're all coded up. There's plenty of examples out there that you can always go look, and leveraging ChatGPT or Claude or Copilot or whatever, you can easily have it generate code for you based off of the design patterns. But you need to know when to apply which design pattern where. This is very important. Okay. Okay. Let's look at the time. Why don't we do this now? Let me stop here before we go into the internals of Spring Boot, because I don't know that we. Yeah. Let's divide up now into breakout sessions, because I want you guys to spend some time talking together about assignment 1A, because it is due tomorrow. So those of you that have already finished or are already further along, you can help those that are a little bit further behind. And those that haven't even looked at it, I would be taking copious notes from your fellow workers. We'll do the students. We'll do this for about 10 minutes. Does that sound okay? All right. So let's see if Darren can remember how to do the breakout rooms. I think I remember how. I want to create, how many people do we have on today? We've got 12, 15. So let's do 4 breakout rooms. That should put almost 4 in every